Hi guys, today we'll discuss this geometry problem from Waterloo's Cayley contest. This is question number 24 from year 2005 and it reads that the base of a triangular piece of paper ABC is 12 centimeters long. The paper is folded down over the base with a crease DE parallel to the base of the paper. So DE is parallel to AB as shown in the diagram. The area of the triangle that projects below the base is 16% that of the area of the triangle ABC. What is the length of DE? Now, this problem requires a very solid understanding of similar triangles and their implications. Suppose I have any triangle on the left, right? It has angles A, B, and C, along with corresponding sides, lowercase a, b, and c, right? It also has a height h. So, suppose I take this triangle, I stretch or shrink, right? I stretch or shrink this proportionally, which means that I keep all three angles ABC intact, right? In this case, I stretch it. Look at this triangle on the right. Well, if I stretch it proportionally, all the sides are going to stretch proportionally as well, right? So the new base is going to be k factors times the original base, right, which is ka, right? And the other side is going to be kb, and the third side is going to be kc, right, where k is any real number. Actually, the same holds true for the height. Height is going to stretch by a factor of k as well, right? So we know that all the length measurements stretch by k. What happens to our area? Well, if you do the derivation, you'll see that the area is actually k squared times the original. So armed with this knowledge, let's try to tackle this problem. So now look at the original diagram, right? You have this triangle, right? We have this little tip right here, shaded area, is 16% of the larger triangle ABC, which is a little bit hard to visualize at this moment. We're given B is parallel to AB, and given the measurement of AB is which is 12. So the first thing I'm going to do is that, because it's hard to visualize ABC, I'm going to take this piece of paper, I'm going to unfold it back to its original form, which is a flat piece of paper. Let's see what this looks, so I can better see ABC and its relationship to this little tip. So let's just draw this out. I have a triangle, right? The base is AB, right? Tip is C, or somewhere near the top. Right? And I have the crease is right here, right? It is DE. And this little tip actually moves to the top, right? So we know that this shaded area is actually about right here, right? DE is parallel to AB, that's given by the question, right? And actually, you'll see that this line, let's call this FG, right? Is also parallel to AB, right? And why can I make that claim? Actually, you see that FG actually comes from AB, right? So this is F, this point, and this is G, right? FG is, because it comes from this point and D is also parallel to AB, so we have three parallel lines, right? And right away, we can see that these are three similar triangles, right? So triangle CFG and CDE and CAB are all similar, right? Because all three triangles share this tip, which is C, right? And I can argue that all of these three angles are the same, right? Because, right, suppose this is alpha. By the parallel lines, right, these are corresponding angles, right? So this is also alpha, and this is the third corresponding angle. And a similar argument can be made about this side, this angle, right? So we know that all three triangles, right, their angle measures are all the same. So therefore, they are proportional to each other using this theorem that we just saw previously. Now, proportionality means that if AB is 12, right? Suppose this, we're given by the question, this is 12, then the length of FG must be some k factor of 12. So it means this is 12 times some number k, right? And moreover, another relationship between the areas, right? We know that the area of CFG is equal to 0.16, or 16% of the area of ABC. And we know from the previous theorem that this is actually k squared, right? Right? The length proportion squared is 0.16, which means that k is equal to 0.4. In other words, this part, FG, is 0.4 of AB, right? And we can find this length exactly if you want. This is actually 4.8, right? We can find that. 4.8. Okay. Then the height, right? Then the height of the smaller triangle CFG must also be 40% of the height of the larger ABC. Okay, so now let's discover the height of it. So suppose, right? Let's call this part H. Right? Okay, what about these two parts? Actually, from the previous diagram, you should see that they're actually the same distance, right? So distance from AB to DE is the same as DE to FG because they were folded just on top of each other. So let's call this Z, for example, right? They're the same. So therefore, we know that the area, the height of the smaller CFG is 40% of the height of 40% of the height of the big ABC, right? So let's write that down. So we know that H, right, the smaller height is equal to 40% of the larger height, which is equal to H plus 2Z, right? Okay, so we can find a relationship between H and Z, right? So you know we can break the bracket first. So this is 0.4H plus 0.8Z is equal to H. So move this to the other side. We have 0.6H is equal to 0.8Z. So Z is equal to 3/4H, right? So this thing is shorter than H. It's 3/4 of H. Cool. Okay, how does this help me find DE? Well, we're almost there, right? We know that the ratio between the size of two similar triangles, it must be fixed, right? So let's explore this ratio a bit. So now the ratio between FG to DE must be the same as the ratio of H to this height, right? So that means the height of CFG is proportional to the height of CDE, right? In the same ratio as the base of CFG to the base of CDE, right? So let's outline this relationship mathematically. We know that 4.8, right, to the height of DE, right? So the smaller to the larger, smaller is the CFG, larger is the CDE, right? 4.8 to D must be, this ratio must be the same as the height of the smaller, which is H, over the height of the larger, which is H plus 3/4 H, which is 7/4H, right? I know that H over 7/4 is simply 4/7, right? So this part, because this part cancels out, 1 over 7/4 is 4/7 is equal to 4.8 over DE, right? Right? So now the last step is just to simply solve for D. Your DE will have to be 4.8 over 4/7, right? Or in other words, you can rewrite this if this is really unfriendly, right? You can multiply by its reciprocal is 4.8 times 7/4,